is relations and functions. And very first thing you have is what a relation is. And all that is, a relation is just a set of ordered pairs. Just a group. This is 3 or 4 or 5 ordered pairs all kind of put together. So it's just a big group of numbers for these. Now here's where it kind of gets more specific for what they're looking at. And this is something that you'll talk about over and over. This is something that we'll talk about in Algebra 2. They'll keep hammering this back home when you get to pre-cal. They're going to talk about domain and range. And domain and range. Domain is just your x values of your ordered pairs. And sometimes they're going to call that the input, because that would be the numbers you plug into an equation. Your range, that's your y values. That is your output. That's the answers you get after you plugged in whatever the input was for this thing. Okay, and I would just have to go back and practice, just getting some practice for what domain and range is. But here's what a function is. Now, there's a longer, more technical definition, but let's just give you the easy, plain English definition here. Functions. You cannot have repeated x values. That basically a function is, if you do this one thing to this equation, if you do this one specific number, you should always get the exact same answer back. If you plug in, it's like making a recipe. A recipe is like a function. If you put in certain ingredients every single time, you should get the same thing out of it every single time. You know, if you put all the eggs and the flour and, you know, all together, one time you get a cake and the next time, you know, you get a pie. Well, that's not a function. It should be you get the same thing every single time on this one. Here's what they're going to do when we're going through these. Here's basically what we're going to do. I'm going to have you list or define, or whatever you want to say for this part. List the domain and range. And then tell if it's a function or not. Okay, and here's what a relation looks like. It's just a bunch of ordered pairs. So you'll have, you know, like 210, 3 8, 4 6, and maybe 5 5 or something like that. Usually it's 3 4, maybe 5. They shouldn't give you a whole lot more than that, but it's just a big list of numbers that you're looking at. Okay, and you should have something like this. They'll tell you, all right, here's the domain, here's the range. Just list all the numbers and tell me what they are. And they should put something like, you know, if it's function, they may give you a yes or no option. They'll have some way of saying, is this thing a function or not? Okay, and again, domain is just your x values. So that's just 2, 3, 4, and 5. And you don't have to list them in order. You can just pull them straight out of the numbers. It doesn't really matter whether it's in ascending order or descending order, just random. As long as you've got all the numbers listed, that's all that really matters. The range then is just your y values. Well, that's 10, 8, 6, and 5. So just list those off. All right. And again, with the technical definition, they make it a lot more complicated, but all you do is you look at your x values. Do any of the x values repeat? They don't. So everyone basically only use the same x value one different time, so this thing would be a function. Okay, so there's one that is a function. Let's show you one that's not a function. Just make sure we know what's going on. Okay, and for your domain, that's just your x values. So we've got 2, -3, -4. Now, and if the number happens to repeat like this one, we had the 2 that was here and here, if you've already got it in the list once, you don't have to rewrite it. So you can say it's 2, -3, and -4. All right, range, that's your y values. That's 4. That's 5, -6, and 10. All right, and because the 2 repeats here and here, it's not a function. Good. Now, they're not going to ask you to explain, just to make sure we got the reason it's not a function is the x equals 2 repeats. It's here and it's here. So if you put in, 2 of whatever, sometimes you get 4, sometimes you get 10. So you never know what's going to happen. Okay, and for all the things they try to make a function be, that's really all you do. You look at whatever the problem is, and if the x value, if there's any x value that repeats, shows up twice, it's not a function. If they only use each x value one time, then it is a function. All right, and now sometimes a couple of ways they may show some of the relations on these. That's where they just list off the ordered pairs. Sometimes on these they're going to do what they call a mapping, which doesn't look anything at all like a map, but it's just called a mapping. So maybe it's something like this. They'll basically go ahead and separate your x and y values out, and then what they'll do is they'll have some arrows drawn to basically say, all right, that would be your ordered pair that would be at -2, 5. You don't think about it that way. This would be like at 0, 7. This one's at 2, 6. And this one would be at 4, 5. Okay, now if they give you these, what they call in the mapping, the domain and range is really easy because everything here, that's your domain. It's just -2, 0, 2, and 4. Your range would be 5, 6, and 7. So if they give you those like that, now sometimes maybe it's in a square box or a circle or whatever, ellipse, whatever it is, it doesn't matter. If they've got your one list over here, one list over here, that's your domain, that's going to be your range every time. And then all you're doing is you're looking at it and saying, all right, are there 2 arrows that come from the same x value? Well, in this case, the -2 goes here, the 0 goes there. There's no repeat of the x value, so this one, that would be a yes. Now, if it helps you over on the side, you could go back and write out the ordered pair, because that would be -2, 5. This one would be at 0, 7. You don't necessarily have to do that. But that way you can at least see what that would look like in order pair form. Alright, one more of those. Let's make this one square. Or rectangle here. Okay, so let's go 10, 20, 30 for the x's, and then 0, 5, and -5 for the y's. Okay. Again, if they give it to you in the mapping, the domain and range is really easy because everything listed under X is your domain. That's 10, 20, 30. Everything listed in your Y, that's your range. 0, 5, negative 5. Alright, and then the function part. Well, you've got 20 could go to the 5 or 20 could go to 0. So because you have the 20 could be two different values for that one, that's not a function. Now the 10's okay because the 10 goes with negative 5. That one's fine. The 30's okay because it goes with a 0. But because the 20 goes two different directions there, then that's what makes it a no. And if they give it to you in mapping, that's the one thing you're always looking for. If there's only one arrow coming from the X value, it's okay. As soon as you have two arrows coming from the X value, that makes it not be a function. Okay. And then the last thing they have you look at to figure out whether something's a function or not is they're going to have you check it from graphs. And there's one easy little test. It's longer to write down what the test is, but to show it to you, it's really quick. But it's basically this. It's the vertical line test. Here's what you're going to do. If you can draw any vertical line, if you can draw any vertical line through the graph, and it intersects, again, intersects is just a fancy way of saying it touches the graph. If it hits it 2 or more times, then it is not a function. All right, now it's kind of, to write it out, it's long. To actually show you how it works, it's really easy, because what they're going to do is they're going to give you a graph, and then all you have to do, so maybe something like this. They're going to give you a graph, something like this, and they're going to ask you, is this thing a function or not? And here's all you have to do. Just start drawing vertical lines through it. There's a vertical line. Hits it one time, that's okay. Here's another vertical line. Hits it one time, that one's okay. So as long as you can draw any vertical line through this thing, and every vertical line that you draw, if it hits it one time, it's okay. So they ask you, is this thing a function or not? Yes, it is. There you go. Now, if you turn this thing sideways, you have the graph going something like this. There's your vertical line right there. You hit it twice. It's not a function. Okay. Now, that's what we're saying. If you can draw any vertical line, doesn't matter, if it's the 4th one or the 1st one or, 15th one. Draw the vertical lines through it. If it hits it one time, you're good. Hits it 2 or more times, it's not a function. And basically, here's what it is. That if we, and you'll have to kind of go back and do this. If we had put this thing on a graph like this, where it was on like an XY axis, this point would be like at 2, 4. This point could be at 2, negative 4. And what the vertical line test does is it's testing all the X values on that one particular line. So if you draw a vertical line and it hits it twice, that means you've got the same X value at both locations. Alright, and then the one last graph they'll do is, instead of it being like a continuous graph like this one, they'll just give you some random dots. something like that. And they'll ask you, okay, do those points, do these ordered pairs on this graph, do they represent a function or not? And all you have to do is this. Whenever they give you a point, just draw a vertical line through that point. If that's the only point on that vertical line, you're okay. Draw another one here. That one's okay. Draw another one here. That one's okay. There's another one here right down the axis. That one's okay. Draw a vertical line through this one. It's okay. Draw one there. That one's okay. Draw one there. That one's okay. So all those vertical lines, if you draw it, they only hit one point, so it's good. Where it would be a no, do this with pencil, so I'm going to go back and erase it. If you had another point right here, that when you drew this line, it hit it twice, hit this point and that point, well, that's hitting it 2 times, so that one would make it a no. So if you take that one out for yes, put that one in right here, that makes it a no. Okay, and that's all the vertical line test is. It's really straightforward. You just draw a vertical line. If you hit it 1 time, you're good. Hit it 2 times, it's not good. And again, it basically ties in back up here. It's like the arrow thing. 1 arrow, we're good. 2 arrows, you're not good. 2 points on the same line, it's no good. 1 point on that line, and it's okay. All right, last thing we've got to do out of section 1 is function notation. And y'all should have seen this back in Algebra 1, but for some of y'all that's been a year, some of y'all that's been almost 2 years, depending on the last time you had some Algebra 1. Okay, function notation. Alright, so here's the big thing of what function notation does. That if you have an equation that replaces y, we'll say in the equations. Now here's where we're going to kind of start previewing the graphing. Now again, we're not graphing today, but this is kind of getting us ready to graph on these. That if you think about some of the equations you had in the past that you were going to graph. Let's say you had y equals 2x plus 3. So remember that's your slope-intercept equation, that 2 would be your slope and the 3 over here would be your y-intercept, so you could graph that one. Here's basically what it says, is that if you had this equation you were going to graph, it looks something like this. Here's what a function is. Here's the only difference of a function. Instead of having y equals, you take out this y and put f of x. Now, here's the only catch with this one, and this will happen every now and again. When you have this f parentheses x, this is not f times x. That when you have that, you read that as f of x. That basically f is like the function you're working with, and x is the number we're going to plug in here. If you're in chemistry, sometimes if you're doing stuff with, a lot of times we'll do problems where distance is equal to rate times time. Sometimes instead of using x, they'll use t because it's the time that you're looking at. Sometimes they'll use r because it's the rate, how fast you're going when you're going through these things. So the letter here will change sometimes, depending on what the variable is you're plugging in. And that just, again, if you're in science especially, sometimes that's going to change. For math problems, a lot of times they'll change that to t because you're talking about the time. Sometimes they'll call it d because you're talking about the distance you're going to go. So that letter can change just depending on what it is that you're kind of working with. Alright, now here's the biggest thing that goes with this one. And here's why they talk about function notations for everything that's here. They're going to ask you to evaluate and kind of do these things that in the past, for an equation, if we had y equals 2x plus 3, they would tell you to plug in x equals 7 or something like that. Alright, and for what we're doing for functions is, it's basically it's a little bit of a shortcut, that for a function, they're going to tell you that you've got f of x equals 2x plus 3. And they're just going to tell you to find f, and where you would normally put the 7 here, you just put the 7 there. That all they're doing is they're taking out this x that you have here, and you're going to replace it with 7, just like you would here. Okay, now, and when I was in y'all's shoes, this was the way I finally got to click and work really easy for me. Is if they tell you to find f of 7, or evaluate it, or however how they want to say it, what I finally figured out is that if they give me this number, I'm going to write down this function I have, and right underneath it, I'm going to put f of 7 like this. And that let me know that everywhere I have an x, I'm going to take out that x, and I'm going to put 7 in its place. So right here, where I have this x, I'm going to take it out, and I'm going to put a 7 right there. And everything else around it, the 2 and the 3, it goes on the outside of the parentheses. So for an equation, they would give you this, and they would tell you to evaluate it or plug in x equals 7. For functions, they give you the function. They just tell you, just find f of 7. A little bit shorter, quicker, easy way of going through these. Okay, here's the one big thing with this one. When you do these functions, you don't do anything to this left-hand side over here. That f of 7, that's just a marker there that you don't really do anything with it. That's just kind of telling you what number you plugged in. All the work is over here on the right-hand side. 2 times 7 is 14. And then do 14 plus 3 to make it 17. Okay, and that would be the answer that you're looking for there. And that would be no different than if you'd taken this 7 and plugged it back into the equation, worked it out, and this would have been y equals. In this case, it's just f of 7 equals, but you're still looking for the 17. All right, let's do a couple more of those just to make sure we got it here. Okay, so new function. So f of x is negative 4x plus 1. For this one, let's find f of negative 2. All right, and again, if it's underneath here, take out x. We're going to take out the x, replace it with negative 2. So over here, you're going to take out the x and replace it with negative 2. And the one big help that you can get for this one is, when you're doing this function part, this negative 2 is in parentheses. Every time you plug it in over here on the right-hand side, put that negative 2 in parentheses. Or if it's positive, put it in parentheses. Because it's in parentheses for a reason. They want you to put it in parentheses when you plug it in, so that it makes things a little bit easier, hopefully, to work it out. All right, so you've got negative 4 times negative 2. That's a positive 8. 8 plus 1 is 9. There you go. All right. Now, on the odd chance that they happen to ask for the answers in order of pair, since this was your x value at negative 2, you plugged it in, worked it out, and got the answer of 9, that would be the answer if they asked for it as an order of pair. They might ask for that in the homework, maybe on an occasional problem here or there, but test-wise, I'll just ask you to evaluate, and you can just circle the 9 and be okay there. Okay, so that's everything, setting up all the parts for what a function is and just what makes it out to be a function. And we'll keep working on that not necessarily in section 2, but when we get to some of the other things in sections 3, 4, 5, and 6, we'll pick back up the function talk a little bit more as we're going through this. Alright, and what we're going to do for the next part here, we're going to do a little bit of 2.2, because it's going to preview where we need to be for tomorrow when we start getting ready to do some graphs. That for 2.2, it's direct variation. Alright, and there is one equation. There's one equation we're going to use for direct variation, and that's y equals kx. Now, here's the whole reason why they're showing you this part of it, because with direct variation when y equals kx, this is really similar to the graphing part that we're going to do tomorrow. That this is, if you take the b value off, y equals kx and y equals mx would basically be the same thing for this thing. And they're trying to show you that for this part of it, when we're talking about direct variation, that's really the exact same thing as y equals mx plus b form, where this one, where the b is going to equal 0. So if we're talking about direct variation, we're always going to start at the 0 value. We're always going to start at the origin. The difference is when we do y equals mx plus b, we're going to change it where we're not starting at the origin. Pretty much, yeah. Alright, and the k for this thing. The k stands for the constant of variation. Alright, so y equals mx plus b is almost the same as y equals kx. You're always going to start at the b value of 0. Alright, now here's what they're going to do to get you through some questions of this one. They're going to ask you, is this a direct variation equation or not? And all you're doing is you're looking at it, and does it look like this where the k could be, you know, any other number that you're looking at? So they'll give you an equation like this, y equals 2x. And they'll ask you, all right, does that fit into that equation? Absolutely, right? Because your k value would be 2, so is that a direct variation equation or not? Yes, it is. Now, they could change that and give you this one. Does y equal 2x squared? Well, that's x squared. That one's just x, so if they give you that one, that's no. Y equals negative 10x. Negative 10 times x, right? So the k value would be negative 10, so that one's okay. Okay, y equals 1/6 x plus 3. Alright, this one said the b value's got to be 0. Is that b value 0? Alright, because it's plus 3, so because of that plus 3 right here, that one's a no. So if you have a number that you're adding to or subtracting to from this thing, it's automatically going to make it a no for this part. And it doesn't matter whether that number is added at the end or whether you added it at the front. As long as you're adding some number to this, because if it was just 4x, that one would be okay, but as soon as you put that 2 plus, that makes that a no. Alright, the only thing I can think of that's close to a trick question on this one would be something like that. Because at first you look at it and you go, well, it doesn't quite look like it because I'm doing y minus 4x. Kind of a trick question on this one. For direct variation, you got to get the y by itself. So this one, they've got the y with the 4x over here. So get rid of the 4x and move it over here. So that's 4x plus 0. Well, if that's 4x plus 0, that's kind of what we said back up here. That's your b value of 0. So that's really the same thing as just y equals 4x. So that one actually would be a yes. So it starts off not really looking like it is because it looks a little different than what we had. But you can rearrange it to get it where it looks this way and not have anything added or subtracted to it. So that one would be okay. Okay, so there's the first part of 2.2, just figuring out, all right, is this thing a direct variation equation or not? Again, nothing really complicated on that one. And now, here's where we're going to show you how you actually kind of use this just a little bit. And we'll do one or two of these, and then we'll stop there and kind of pick up the rest of it tomorrow. Some of it will be that way, yes. Now, here's some of the other homework that we'll get in section 2. And we're not going to get all of it today. We'll get a little bit of it. So if you want to grab a Chromebook, we can let you look at some of it. Okay, so for some of the parts on this one, still talking about direct variation, but what they're going to do is basically give you some word problems here. And with the word problems, this is almost like a two-step problem when you're going through these. So they're still going to tell you this is a direct variation equation. So step one is you have to determine, or you've got to figure out what the k value is. Now, and it's easier than what you think, because the one equation we're going to keep using is y equals kx. So as long as they tell this thing is a direct variation equation, we're always going to come back to this one equation with this part. And the first half of the problem, you're just going to plug in those two numbers from the first half of the problem. You've got y is 6, you've got that x is -9, and so the k times that part would go there. So whenever they do, and every problem is going to be the same way. They're going to give you this sentence of everything that's here. You're going to have to find the different values. But the first half is basically you're going to use that to help you figure out what the k value is, which again is basically like your slope. Once you've got that value and you've got your slope, then you can take any number you want to plug in and you can find out the number that would go with this thing. For this part, we've got 6 equals k, and that's really k times -9. So to get the k value by itself, we're just going to go back and divide both sides by -9. That way the -9's will cancel. You've got the k here. That's 6 over -9. And we'll put the k over here because we've got it there. Now for this one, you do have to simplify because you can divide both of those by 3. So that would make that a -2/3. Alright, now before you get too excited, because sometimes people get excited and they'll stop there. That is the k value that we need. But it's not asking us to find k. We've got to figure out what x is when y is 12. So what we're going to do then, so that's your step 1. You find out what the k value is. Step 2, you're going to plug in your k value. And then the other value from the original problem. And every single time on this one, we're going to keep using this y equals kx thing. So from this problem, we knew that k is -2/3. Now, where you put the negative, it doesn't really matter whether you put it with the 2 or the 3 or just put it out front. As long as there's a negative in there somewhere, it's okay. And let me scroll back up real quick. The one thing from the problem, because now we've used everything here, the one thing that's left is y equals 12. So now we're going to plug in that 12 for y over here. Alright, now with this one, sometimes that fraction throws people off a little bit, so let's just do this. You can put that x on top, so it looks more like that, if that helps out. Sometimes that x in the middle throws people off a little bit, so if you want to, you can just put the negative 2 times x over 3. Ooh, here's a good flashback to chapter 1. If you're solving an equation with a fraction, and we don't like fractions, what do we do to get rid of that fraction? Well, you're dividing it, so to fix the division, you got to, there you go. So you got to multiply both sides by 3, so now you multiply this side by 3, and multiply this side by 3. Now, in doing that, again, that will cancel that part out. So we got 36 equals negative 2x. And that's pretty easy. Take 36 and divide it by negative 2. So that's just a negative 18 for your x value. So what they're doing with these word problems is they're getting you ready to keep working with the y equals kx. Just having you play around with it, that you can get values from it. You can always get the k value, which again is really the same thing as slope. So they're really doing all this work to get you comfortable working with slope again, because this would have given us a slope of negative 2/3. We'd go down to over 3 to use the slope on this thing. So it's all a preview thing to kind of get you ready for slope as we're going through this. All right, let me show you one more thing, one more little part with this one real quick, and then we'll be done. All right, one other last thing we'll look at, and this will be pretty short. All right, let me go back here. Sorry. Let me put this first here. Let me get the directions first. Does the diagram represent a direct variation? And if it does, find k. And write an equation. All right, we'll keep this one short. We're only going to need 3 sets of numbers. And now, for these problems like this, what they're really asking is, do they all have the same k value? Do they all have the same slope is basically what they're asking for. Are all these points on the same line is kind of what they're looking at. And to do that, for this part of it, that we're trying to figure out what k is, and here's where we use this equation from back in chapter 1. That if we're starting with this equation. If you've got to get the k by itself, you've got to divide by x, right? So k is really y divided by x. So it's kind of like a little side note over here. Okay, well if all we're trying to do is figure out what the k value is, that means that what we need to do over here is just take the y value and divide it by the x value. So it's negative 21 divided by 3. Negative 7, right? Okay, we'll do the same thing with the next one. This is 28 divided by negative 4. That's also negative 7. Negative 35 divided by 5. Also negative 7. So they all came out to be the same number. And if they all come out to be the same number, then that means that's a yes. It is a direct variation equation, because we're doing the same thing over and over and over for all these parts of it. So the k value is -7. And for the equation, here's where the equation gets really easy. Instead of just doing y equals kx, because that's your direct variation equation that you always come back to, just plug in the -7 for the k. So y would be -7 times x. So there's the first answer, yes it is. There's the second answer, the k value is here. And for the equation, you just plug in your k value to get the equation that they're looking for.